Hello participants. Now let us move to the topic SAP HANA architecture and deployment scenarios. In this topic, we will understand the software view, execution architecture, different process components in SAP HANA, and implementation options, deployment scenarios with SAP HANA. This slide shows the picture of SAP HANA software view. HANA software view shows different layers which act as different components to serve the incoming request from the end user. So, to support the incoming request from the end user, we first have the client interaction interface layer, also called as the analytical interface layer. This analytical interface layer offers different client interfaces possible to connect to SAP HANA, like for example, you can name SQL, SQL script, MDX, REST, and many other for different source types. And here, SQL is the main interface for custom developed apps and client applications for SQL queries, and MDX for multi-dimensional queries, and as I said, REST also is used and it supports HTTP based queries. HTTP means all web-based queries, and these are supported by different client libraries for various platforms supported. Moving on to next layer. Next layer is the application logic extensions. Application logic extensions offers text analysis component and client applications for SQL queries as shown above, which will use AFLs. AFLs are application function libraries. And here the text analysis component, which is a component of preprocessor and is used for text search on the HANA data. And as I said, AFL, which stands for application function libraries, has BFL and PAL. BFL is the business function library and PAL is predictive analysis library. And these libraries are managed by AFL framework and are basically used to execute application logic within C++. And coming to BFL, BFL is a function library which works as reusable library for business applications, and PAL defines functions that can be called from within SAP HANA SQL script procedures to perform analytic algorithms. So these function libraries would act as predefined algorithms for various developments to be done by developers. In earlier traditional databases, developers had to write their own algorithms for using them in the development procedures. But in SAP HANA, it offers these predefined libraries which will act as the algorithms for use in development. Now moving on to next layer, we have the parallel calculation engine. Calculation engine is the common execution runtime for modeled calculation views, SQL scripts, MDX queries, and planning engine operators. HANA operates primarily on these calculation modules, which are a part of calculation engine. Now let us move to next layer, which is the in-memory store. In-memory store offers different data stores of the SAP HANA database. A store is basically a subsystem of the SAP HANA database, which includes in-memory storage as well as the components that manages the storage. And coming to SAP HANA database has the following store subsystems, that is the row store, the column store, and there is also the disk-based store and the object store. The row store, the column store, and the disk-based store maintain data in relational tables in the database. Relational store, as I said, as row store and column store. We have understood that row store originates from T-star time database and column store from TX technology. Disk store is basically the tracing data or old data that are not needed in memory anymore. And coming to object store is an integration of SAP Live Cache technology into the SAP HANA database for running live cache application. So overall, with all these layers offering different functionalities, together we can say that SAP HANA as an application packaging can be used as an appliance for any implementation, which is termed as the managed appliance. Now let us understand the execution architecture of SAP HANA. From technical execution point of view, which are the different components which help in execution and how does they work is what we will understand here. Coming to the first layer here, see, this is the business application which will talk to SAP HANA database. This section is the SAP HANA database. Now let us first consider the connection and session management layer or the component. This component, which is placed at top, creates and manages sessions and connections for the database clients. Once a session is established, database clients typically are SQL statements to communicate with the SAP HANA database. So this session management will offer the interaction layer with the business applications and on the other side with the SAP HANA database operational components. Now in the SAP HANA database, each statement is processed on or basically in the context of a transaction. New sessions are implicitly assigned to a new transaction. So there comes transaction manager into picture. The transaction manager is the component that coordinates all transactions within SAP HANA database. It controls transactional isolation and keeps track of running and closed transactions. So basically when a transaction is committed or rolled back, the transaction manager informs the involved engines which were operating on this transaction about this event so that they can execute necessary actions needed. Now coming to metadata manager. What is a metadata manager? See, metadata can be accessed via this metadata manager component. In SAP HANA database, metadata comprises a variety of objects such as definitions of relational tables, columns, views, indexes, and also procedures. Next is authorization manager. The authentication component is invoked when a new connection is established. New users are authenticated either by the SAP HANA database itself, basically regarded with a login user and password, or authentication can be delegated to an external authentication provider as well. And this authorization manager is invoked by other components of the SAP HANA database to check whether the user has the required to check basically whether the user owns all required authorizations or privileges to execute the requested operation. So the authentication of any user trying to operate on the HANA data is validated by authorization manager. And coming to execution engine. Execution engine is responsible for processing all execution plans within SAP HANA database. And there is a text engine which implements the single column search operations like exact search, linguistic search, and fuzzy search. And there is also another engine called planning engine, which allows financial planning applications to execute basic planning operations in the database layer. Now coming to persistence layer, which is the bottommost layer, which contains logging and recovery, data storage. The SAP HANA database persistence layer stores data in persistent disk volumes that are organized in pages, and these page sizes are different and are supported between 4K and 16 M, 4 kilo and 16 megabytes. Data is loaded from disk and stored to disk page wise. So disk storage is mainly present in persistence layer. And for read and write access, pages are loaded into a page cache in memory. So in simple words, persistence layer is basically used for storing data and log volumes and also the backups. So for data safety, this persistence layer stores all data and logs in forms of disks. In other words, volumes. Now moving to next slide. This slide shows SAP HANA database components from execution point of view. See that this shows different HANA-DB components, also regarded as different HANA-DB processes. See that client applications are talking to HANA database through different interfaces available, and within HANA database we have different components. First most important component is the index server, which contains the actual data stores and the engines for processing the data. This index server is primarily responsible for all calculations that runs in HANA DB. Next, moving on to the name server. Name server owns the information about the topology of an SAP HANA database system. For example, in a distributed setup with instances of the SAP HANA database on multiple hosts, the name server knows where the components are running and which data is located on which server in the distributed setup. Now moving to statistics server. Statistics server collects information about status, performance, and resource consumption from all components belonging to SAP HANA database system. Monitoring clients such as SAP HANA Studio access the statistics server to get the status of various alert monitors. So basically, statistics server uses a set of system tables and monitoring views to collect the performance statistics of the SAP HANA database as a whole, which can be further used for analyzing the performance of SAP HANA. Next is the Access engine. Access engine is an optional part of the SAP HANA database. It allows mapping the persistence model in the database for a consumption model that is exposed to clients via HTTP interface. It also contains the services that expose the search capabilities of the SAP HANA database to the web world. So basically, Access engine offers the web service, that is, it serves all the web requests. And the preprocessor. Preprocessor is a component of HANA database which works on the unformatted, that is unstructured data coming into SAP HANA database. Now, what is this SAP HANA Studio? SAP HANA Studio is an Eclipse based tool. Basically, it is developed in Java and based on the Eclipse platform. It's a GUI based tool and it offers both the development environment and the administration tool for the SAP HANA database. And this SAP HANA Studio accesses the SAP HANA database via SQL interface using an SQL port. So we can do development activities, administration activities, modeling activities, replication activities using SAP HANA Studio. And this box below shows the process names of different components. All the processes start with HDB and the component name follows after that. So here we see we have HDB name server, HDB index server, HDB statistics server, HDB preprocessor, HDB access engine, and HDB daemon. HDB daemon is the parent of all other components. It starts, stops the other processes in the right order and also monitors. So to say that an SAP HANA database is up and running, we must make sure all these processes are up and running. Basically, in simple words, they are available. Now let us move to the next slide, which speaks about different product offerings from SAP HANA. SAP HANA software is basically available in 3 editions: Platform Edition, Enterprise Edition, and Enterprise Extended Edition. Platform Edition is the basic edition which offers a set of components like HANA Studio, HANA Information Composer, HANA Client, Client for Excel, HANA UI for information access, that is INA, HANA Database, Workstation, and Diagnostic Edge. And coming to Enterprise Edition. Enterprise Edition along with Platform Edition offers additional tools for replication. So to use the replication technology in SAP HANA, Enterprise Edition comes with additional replication tools like Business Objects Data Services, HANA Direct Extractor Connection, Landscape Transformation Add-on, Landscape Transformation Replication Set. So these replication tools are used for different solutions to replicate, be it SAP or non-SAP solutions, to replicate their business data into SAP HANA and leverage the functionalities of SAP HANA. Now moving to Enterprise Extended Edition, it's an extended Edition to Enterprise Edition, which offers additional components like HANA Load Controller, Sybase Replication Server and Agent, and Sybase Adaptive Server Enterprise. So it is more or less same as the Enterprise Edition, but with 3 additional components. So based on the implementation scenario and the desired results required, we choose the edition and implement. This slide speaks about the implementation scenarios, basically the in-memory strategy, and also shows the roadmap that SAP HANA has come through. Initially, SAP HANA was offered as a sidecar scenario, that is basically analytics sidecar implementation scenario. So where SAP HANA technology was used for real-time operational analytics, basically in terms of data march, like for example agile data march or operational data march or accelerators. So basically RDS and accelerators were a part of analytics sidecar implementation scenario. So when SAP started with this, they had real-time operational analytics, and from there they decided to have SAP solutions be powered by SAP HANA. So the next implementation scenario was the primary persistence scenario, wherein we had SAP NetWeaver BW solution powered directly by SAP HANA technology. So in this primary persistence technology, we had SAP solutions directly being implemented on SAP HANA database. That is basically SAP solutions used SAP HANA database as a primary database, wherein in analytics sidecar scenario, SAP solutions used SAP HANA database as a secondary database. Data from SAP solutions were replicated to HANA database, which is regarded as the secondary database, and then functionalities of SAP HANA were made use. Whereas in primary persistence, since SAP solutions are sitting directly on SAP HANA database, they could use the SAP HANA functionalities directly. Smart metric analytics is one of the examples of this scenario. Moving on, we have platform implementation scenario where SAP HANA was implemented as a standalone platform. And in this scenario, we have SAP Business Suite solutions powered by SAP HANA. Business Suite solutions like SAP ERP, SAP CRM, SRM were directly implemented on SAP HANA. So basically, applications directly used SAP HANA services, and also there are a lot of standalone applications which can be built directly on SAP HANA database in the platform implementation scenario. So the current scenario is platform based and as well as primary persistence based. Let us understand more about these scenarios in the coming slides. This slide speaks about the deployment option called operational data march. See, basically, as I said in the previous slide, we have SAP Business Solutions using one of the traditional databases as the primary database, and at the same time it is making use of SAP HANA database as a secondary database, and the data from the SAP Business Suite solution is pushed to SAP HANA using the replication technologies available, and thus it is leveraging the SAP HANA functionalities. In this, operational data from source system can be replicated to SAP HANA for flexible operational data match and query performance by either using real-time replication or periodic load. So these technologies can be used for either real-time replication or periodic load, and thus data from operational system is loaded into SAP HANA. After the database structures and data are loaded into SAP HANA, they can be modeled with the on-fly aggregation for operational reporting needs without any data duplication. So any kind of reporting can thus be done on the data present. So with available SAP Business Suite data services, selected analytical models can be copied from data warehouses, be it SAP or non-SAP, along with ad hoc or line of business data sources to SAP HANA database for agile data. So ideally, any complex transformations from multiple systems can be handled in SAP Business Objects Data Services and loaded to SAP HANA for highly flexible modeling extensions of analytical models and modeling. And for real-time replication, we use the SI technology. So basically, what is the core value? We can have real-time reporting on the entire operational business data. Now moving to next slide. This shows the second deployment option, which is as accelerators, where SAP HANA is used as accelerators. SAP HANA further supports a new breed of applications called suite accelerators, which accelerate existing SAP Business Suite applications through a side-by-side approach where SAP HANA is deployed with SAP Business Suite applications. And these accelerators leverage SAP HANA as a secondary database again, keeping the existing application UI as it is. And database tables that are needed for accelerator are replicated into SAP HANA using the same SLT replication or data extractor connector. So here the data access of the application is executed against the replicated tables. In the SAP HANA database instead of the primary database below the application server. So the tables from here are replicated to SAP HANA, and applications will directly use the replicated table sitting on SAP HANA database. So what are the core value proposition? So we can say this can act as a turnkey accelerator for all SAP ERP customers. And speaking about examples, SAP COPA Accelerator software is one of the first solutions delivered to SAP customers using this accelerator functionality. Now moving to next slide, this deployment option shows how SAP HANA is used as a primary persistence, that is, in simple words, as a primary database directly. SAP NetWeaver BW solution can be accelerated by using SAP HANA as its underlying database. Basically, in this scenario, SAP NetWeaver BW functions, such as those of SAP NetWeaver BW Accelerator software and new SAP HANA optimized information providers. By providers, I mean objects within a database that act as a data providers within a query definition, are basically performed in SAP HANA to benefit from its in-memory and calculation engine functionality. So basically, while implementing, We build SAP Business Suite solutions to use SAP HANA as a primary database. So thus we achieve all objects and BW loading procedures get accelerated by in-memory technology directly, and it also offers high modeling flexibility. So this scenario also includes the SAP Business Objects Planning and Consolidation application, basically the version for SAP NetWeaver. And this implementation is available as of release 730 of SAP NetWeaver BW with the support package level 5. This feature eliminates the need of a separate instance basically for SAP NetWeaver BW accelerator. So thus using SAP HANA database as a primary RDBMS. And similarly, you can have other SAP Business Suite solutions like SAP ERP, CRM, SRM, which can be implemented directly on SAP HANA using it as a primary database. So what is a core value proposition? Here we can have speed and simplification for SAP NetWeaver BW as well as SAP Business Suite solutions. Next deployment option is SAP HANA platform. Here SAP HANA technology can be implemented as a platform, a standalone platform. SAP has started a new wave of business applications that are designed, developed, and optimized to take full advantage of SAP in-memory computing technology. So basically, new applications can be regarded as next generation HANA applications can be powered by SAP HANA, and these include, for example, SAP Smart Metric Analytics software, SAP Dynamic Cash Management application, SAP Sales and Operational Planning application, SAP Lumira. So using this option, we can implement standalone applications on top of HANA for obtaining different functionalities of SAP HANA. So with this goal in mind, going ahead, SAP is more focused on implementation of SAP HANA Application Cloud, that is HANA on Cloud, which is an on-demand application environment based on SAP in-memory computing technology. And applications delivered with SAP HANA Application Cloud allow customers to immediately leverage the benefits of SAP HANA through easy to use scalable cloud-based offerings. So as I said, we can leverage SAP HANA as a platform and build standalone next generation HANA applications on top of it. Could be iOS application or Java applications running on top of HANA. So what is the core value proposition? Core value could be simplification, lean code, lean apps. So now we have understood different implementation scenarios or deployment options available in market with SAP HANA. So with this, we have come to the end of this topic where we have understood the architecture of SAP HANA and the editions of SAP HANA available, the execution components involved within SAP HANA, and various implementation scenarios or the deployment options possible with SAP HANA in the current trend.